for a few more people to come in. So hello everyone. How is everyone today? Good to hear. So my name's John Hammink. I'm a developer evangelist with a company in Tokyo, Japan called Treasure Data. And I'm going to talk to you today about some of the open source tools for handling big data. And I'm also going to talk to you a little bit about kind of the scenario of big data, how it has evolved to the present day, what some of the common terms and terminology are, and what sort of the basic context of the idea is. Now, originally in this talk, I was going to focus merely on data collection, but I realized that data collection isn't going to be a very long talk at all, since collecting events from code is actually pretty straightforward. And it works pretty much the same way, regardless of any programming language you're using. So I am going to show you a few examples of data collection, data ingestion, looking at some analytics. Of course, I'm going to use the platform that I know best, Treasure Data, as a way to show you how it's all working. That said, it isn't really an advertisement for one technology over another. Just giving you kind of a rundown of the concepts and how things work together. Does that sound like the kind of talk you'd be interested in hearing? I think everyone's asleep, so I'll try to make loud noises and go bang a lot, so people don't, fall asleep into their coffee. What I want to do is I want to look at the problem of big data. Why do we talk about this thing in terms of big data? I want to give this a little bit of context as well. So what is the historical context? Like, what do things look like? Why are we here today looking at this problem? I'm going to give you some alternatives as to what possible big data solutions might look like, especially in the context of open source. We're going to look at and demo at least a few open source tools that enable big data collection, big data ingestion, querying and analytics and that sort of thing. And specifically, we're going to look at mbulk, which is a data transport tool. Very quick demo on that. And then I'm going to show you an actual demo that I've written, a little iBeacon demo. So it's a little Ruby application that mimics the iBeacon, which is a beacon you'll see in stores in some place. And it enables, this sort of thing enables merchandisers to track like where people are going in the stores and that sort of thing. So we'll have a look at that as well. I have taken, of course, the liberties of presenting a little bit more of the business context, sort of the why of collecting data. So without further ado, a little bit about me. So I am originally a software engineer. I worked for this data security company called F-Secure in Finland back around, and this makes me sound very old, but the turn of the last century, 1998, 1999, I was living in Finland. I'm not from Finland originally, but I picked up a little bit of Finnish accent from living there. I ended up working for this little-known startup in Tallinn, Estonia called Skype that you might have heard of. I was one of the not the original engineers, but kind of the Gen 2 engineers there. We watched this company scale massively in a very short time. I think when I started there, we have something like 10,000 active users, and we grew to 10 million users in the course of about a year and a half. So, of course, I had a sense of seeing what an information kind of explosion looked like in the context of working in one place. I worked for Mozilla for several years as well, more recently on the team that was working on Firefox OS. And in fact, I presented on this very stage 3 years ago some of the web APIs for Firefox OS with Christian Heilmann. So what is the problem that we're describing? What is the kind of thing we want to solve? Well, the data stream itself is actually exploding. The amount of data that's coming out of devices, the amount of data that we want to learn about users, the amount of data that we want to, glean to understand insights from, it's exploding right now. To give you a sense, there's more data coming in the last 2 minutes from all the collective devices on Earth than there was basically data in all of recorded history between the beginning of recorded history, if you will, and the year 2000. So that's just a massive amount of data that's coming ever faster and with greater velocity than ever before. There's also many, many more sources for collecting data instead of just transactions, right? So if you think of a transaction, you think in terms of like, for example, a bank transaction. We used to think, well, these are all the things that really matter. But actually, we're doing a lot more than that now. A customer transaction, a bank transaction, is something that I'm going to differentiate from the big data that I'm talking about. And the big data that I'm talking about is the kind of stuff that we collect, for example, from IoT sensors, from web page clickstream, from event logs. If I'm running, for example, test automation, and I have 40,000 tests, and I want to understand where the nature of the failures is, it's too big of a set to try to isolate, for example, individual failures. But what I can do is log, for example, events in each one of my automated tests. And then, based on where my failures are occurring, I can start to do queries on this large data set. So what I'm in effect doing is creating a very large statistical sample and running analysis on that. And that's the kind of data that I'm talking about here when I'm referring to big data. So not the transactional data. Unfortunately, well, or fortunately, depending on how you look at it, that stuff is here to stay, but it's in a different bucket than what we're talking about today. There is a lot needed to do if one wants to capitalize on this idea of big data. When I'm speaking in terms of data science, what kind of competencies am I talking about? What kind of people do I need to get into my organization? If I'm talking about data engineering, what needs to be part of a data analytics pipeline? What parts need to be there? And more importantly, how am I going to maximize any kind of return on investment I make on all of this stuff? Well, unfortunately, I'm not going to have all of the answers for you today. But I'm hopefully going to give you some of the kind of questions you want to ask when you're starting to think about setting up a kind of an infrastructure. First of all, there's trade-offs, right? If I want to set up a data backend, I need to consider the difference between bare metal performance. So how many of you out here are application developers, and how many of you of those, actually let's have hands up for all the application developers out there. How many of you are running your own kind of data backends on something like MongoDB? Okay, so there's a few. MongoDB is a great solution. There's a lot of great things about it, and you can run it, for example, on an SSD and get lightning fast latency and lightning fast lookups. How many of you who are running MongoDB have been thinking about, for example, scaling to much larger installation base for your MongoDB? How many of you are fretting about, for example, the sharding and replication and scaling strategies? I see no hands up. That's like unusual. Somebody in the back scratched his head, so I'll count him as one. How much of you guys would like your life a whole lot better if you didn't have to deal with thinking about that stuff at all? Okay. Got a few very tentative hands up, so that's good. Well, there is a trade-off between a bare metal performance, if you're running MongoDB natively, as opposed to if you're running your big data analytics pipeline, for example, in the cloud, right? There might be slightly longer latency, but never having to think about scalability at all is actually a very compelling argument. Say you release an application on the App Store, and yesterday you have 5 downloads of it, and the next day it goes viral. How do you handle that massive influx of data? How do you deal with this huge growth in the amount of data? I mean, no doubt you're going to have some kind of a headaches to deal with there. So I'm going to talk to you a little bit about some of those. So as I said before, the amount of analyzable data is actually rapidly growing right now. So who can tell me what a zettabyte is? How much information is in a zettabyte? Okay, nobody? I think everybody's asleep, man. We should pass coffee around or something. A zettabyte is actually 1 trillion gigabytes. And then we're saying that by 2020, actually by now, we already have in our digital universe, we have something between 3.2 and 5 trillion 3.2 and 5 zettabytes in the universe by now. But by 2020, that number is going to grow to 40 zettabytes. That's 40 trillion gigabytes in the digital universe. So by 2020, we're going to have at least 50 billion internet-enabled devices in existence, according to Information Week and Gartner and a bunch of these others. And every 2 days, there's more information created than existed between the dawn of time in 2003. And in every 2 minutes, there's more data created into the digital universe in the entire world than existed from the dawn of time to the year 2000. So think about that. In 1 day, we create enough data to fill DVDs to stack to the moon and back. And there are, at least every single minute of every single day, at least 570 websites created. So you can imagine there's this massive amount of data that needs to be leveraged. And what's interesting is that actually companies aren't using almost 88% of the data that they collect. So that makes for some interesting ideas, right? You're collecting all of this data, but you're not really kind of leveraging it very well, or using only a small part of it. Now, for the cloud service that I work for, Treasure Data in Japan, and it's one of many, I should say, we alone ingest something like 600,000 events per second, right? Now, on this graph, the range here is from 0 to 14 trillion records. This thing says that we've had about 13 trillion records over the last decade, from October 12th up to October of 2012, up to about January of 2015. As of July 1st, we're importing 60 billion records a day. This comes out to about 1 trillion records every 20 days. So this means that of this entire 2.5 years on this graph, we're going to take in as much data in the next 260 days, assuming that the path is linear, which of course is not, because it's growing exponentially all the time. So that's something to think about. And of course, your own data is going to explode too. So what I would like to kind of do, if anyone's interested in actually answering, if anyone's awake yet, is ask around, like, what are some of the ways that you guys are collecting data and using data? So do we want to pass a microphone around, or do people just want to yell? Yeah. It's okay. Okay, all right. So we're going to ask you in Portuguese, what are some of the ways that you're collecting data right now? Anyone?
O João quer saber o que o pessoal de aqui está trabalhando, fazendo a coleção de dados. Já seja MongoDB ou algum tipo de solução de storage. Tem pessoas trabalhando nisso agora? Aí tem uma pessoa.
Yay, we have a taker.
Em chamado de equipamento que conta veículos. Então, em resumo, em uma rodovia movimentada, em um mês eu tenho aproximadamente, não é muito, mas como é mais de uma rodovia que eu conto, 1 milhão de registros por arquivo. E eu recebo tudo isso em arquivos de texto plano, em dado estruturado e em texto, de certa maneira, porque o equipamento é antigo, né, e ele conta no cartão SD. De certa maneira, tudo isso que eu recebo, a quantidade de informação que eu consigo extrair disso é muito pouco hoje. Então, eu acabo guardando esses arquivos de maneira em texto plano e extraindo informações de relatórios de 15 em 15 minutos, de 5 em 5 minutos, e acabo não utilizando realmente toda a informação que eu tenho, né? Então, o meu problema hoje é, assim, vale a pena eu guardar essa informação registro a registro em banco de dados, ou vale a pena eu manter isso em arquivo e processar em lotes quando for necessário? Então, hoje eu guardo os dados em texto, mas eu gostaria de achar uma solução ou saber se essa é a solução correta para ser feita. Então, é assim que eu faço hoje.
Mm-hmm. I guess I didn't quite get all of that, but yeah, my Portuguese isn't as good as it should be. Okay, anyone else want to tell me about how they're collecting data? Anyone?
Hello.
Yes.
Today I'm working in a CDN, software-defined CDN.
Oh, great.
So we have logs from billing, from analytics, and from us to study errors or events that occurs in your servers.
Okay.
We collect logs for analytics with Cassandra, okay, and Storm and Kafka. You know about softwares?
Mm-hmm.
Yes. And logs for billing or for us in the server and with a storage, okay, with AirSync. Just it.
Oh, okay. Thanks for sharing. Anyone else? Who else collects data? It seems like a whole lot of you collect dust. Well, okay, trust me on this. There's many ways to collect information. So in addition to the whole RDBMS, the whole transactional data that you collect in the course of a day, there's other things as well. So there's clickstream events. If I have a website, I want to know who's clicking to my website. I want to know about referrers. I want to know about page views. I mean, anyone in this room use Google Analytics? Okay, we've got a few more hands up. Yay, I think people are waking up. So that gives you kind of an example. Most of the Google Analytics is drawing from events that are placed, as you know, somewhere in the code of the page, right? When the user is executing certain code or going past certain line of code in the page, it generates an event. The event is logged and it's tracked somewhere. I mean, this is fairly obvious. IoT sensors are another case. So imagine a case where you're a hotel, you're a very large hotel chain, like Marriott, and you have something like 2 or 3 million of these Nest thermostat devices running. Wouldn't it be useful to do the kind of analytics or the kind of comparison between having, for example, a cold snap in the northern half of the United States and Canada and tracking power consumption from that? That's the kind of thing where this kind of analytics on a statistical base becomes very useful. Of course, as I mentioned before, there's event logs as well. So I used to work at Nokia. I worked on the MIMO project. And we had something like 40,000 automated tests running. I mean, when we had to track failures, it wasn't always possible to track down each and every single one of them because of the sheer volume of tests that were running. What we were able to do is see where there was a failure, we could pull the data in and we could start to query, well, was it failing after this kind of an event, or was it failing after that kind of an event, or so forth. So, of course, there are events in terms of calendar events as well. So for example, if I'm running a site like wish.com or amazon.com, and I want to see how, for example, buying patterns are changed on a certain day or after a certain day, like Christmas or Easter, for example, those are really obvious things. The same thing goes for mobile data as well. If you have a game, you're going to want to be able to track how certain users are getting to a certain point in the game. How many users are, for example, monetizing the choices they make in the games. So that's all fairly obvious stuff, right? But what is after all the point of all this data, right? Again, we're not talking about the kind of transactional data that you might think of in terms of bank transactions or financial transactions on a website. You are thinking about collecting a large portion of data that you can run statistical analysis on, that you're going to sample. And ultimately, what the point of all this data is it's business intelligence using very large sets of data. You want to be more responsive for the next iteration. By gleaning insights from what you already know. So in terms of the history of big data, I mean, the whole point of this is that we saw an enormous explosion of data coming almost from the turn of the century, like when Google launched in 1998. We suddenly needed to track not only web pages as well, but we also needed to track searches because we wanted to know how to populate search results and how to gain insight into what was relevant about search results. And the same thing is true, actually, in terms of Wikipedia, right? We wanted to be able to track, for example, how many people are writing articles to Wikipedia and which of these articles are being searched and so forth, so we can determine some kind of a relevance there. The two big things that emerged kind of over the last decade and a half were the MapReduce paper, which was written in 2005, and Apache Hadoop, which came out the year after that. Apache Hadoop essentially reduced any kind of operation on a large set of data to two things. And you probably know it's map and reduce. Taking a large set of data and basically converting it to two operations. So in the map phase, what we're doing is we're emitting the data, and we're extracting from it a set of key value pairs. And in the case of MongoDB, we're doing this at one iteration per shard, right? We group this by key, we sort it by key. We're doing a simple reduce operation. We're extracting the keys from the values. And finally, we return an index of a series of key value pairs back to whatever our data store is. So pretty much enough of all that. We can talk about big data and what kind of a profit it is. We know that there's a 60%, if we look at data from, for example, Information Week, we know that there's a 60% increase in profit margins that retailers are getting when they use data analytics well. We know that there's a 5 to 6% increase in productivity and profitability across all industries. And we know that there's a 15 to 20% average return on investment if a data infrastructure is implemented well. We can say that arbitrarily a value that they extracted for the global value of data is between 150 to 200 billion. So whether you're using it or getting in the business of it, it's certainly profitable. And some people in Brazil are already getting it. Like there's popular marketplaces in Brazil that are already leveraging this. So it's nothing new, right? Americanas.com.br is one really good example of this. And Submarino in Brazil is another example. And of course, you have your own eBay equivalent, which is mercadolivre.com.br. So when I'm thinking in terms of this, what do I actually need to capitalize on big data? And this is admittedly some of my own graphics because I didn't want to go to Shutterstock, so I pulled some of my own art out. But one of these funny-looking things, the one on the top left represents infrastructure. So what kind of infrastructure do I need to capitalize on this? The one on the top right represents data. So what kind of data do I need when I want to start thinking about this? What I need to capitalize on this. The one in the bottom right, which I actually did get from Shutterstock, is like, what skills and resources do I need to start thinking about collecting? And finally, for analytical capabilities, which ones do I need to think about? And to give you a few hints, there are a few intro to data science blogs at our website as well, blog.treasuredata.com, so you can learn some introductory bits on data engineering and data science, as well as Python and Ruby for data collection as well. Now, you've all heard the classic arguments about, and you're probably pretty much close to the idea of closed source, which seems appropriate. So am I, actually. But open source, being free, occurs additional costs in implementation and resources. So we say that open source's main advantage is not cost. Who wants to hazard a guess how much Facebook spends on MySQL every year? Again, the only thing I hear are crickets. Well, the answer to that question really depends on who you ask. Because MySQL itself is, of course, free. But Facebook spends tens of millions of dollars a year on paying the MySQL mad scientists to prop up and build the actual infrastructure around it. So, of course, it's nothing if you count the software, but this is going to be millions yearly if you count the people you need to employ the software. So, obviously, one of the most important things for big data, and I'm going to get onto the good stuff here in a second, is, it went away, cost, but also the freedom to innovate. Because open source gives you a lot more leverage, but you have to know, for example, how to use it. So as before, there's a difference between data that we're collecting for short-term statistics and data that we're collecting for posterity. Because when we're collecting data for short-term statistics, when we're collecting data for streaming, we have to ask ourselves a few questions. Is it a small system? Does latency count or not? And do I have the resources to spend on sharing or replication? In the case of something like this, MongoDB, or some kind of a document database or key value database, can be incredibly useful, right? But if I'm collecting data for long-term posterity, so over a long period of time I'm going to be collecting several trillion records, then I have to start thinking about the whole scaling headache. Do I want something, a solution that's going to scale for me automatically? Or do I want something that I'm going to have to really be more in tight control of? In the case where you're happy to deal with the infinite scaling, but latency, for example, isn't an issue, you might consider something analogous to, and I'm not suggesting these specific solutions, but something analogous to Treasure Data or Google BigQuery that you can build in the cloud, and it's going to scale and replicate automatically. Because what is, after all, the trade-off? Well, if I build something in the cloud on the equivalent of, for example, AWS, I'm going to be able to scale automatically if I set up that day. So if I have an application that's getting me 5 events yesterday because nobody's bought it yet, and it's getting 1 trillion events tomorrow, do I really want to deal with all this scaling headache when I have other problems that I'm going to have to solve, right? On the other hand, when I'm running something on bare metal, like these SSDs pictured here, I'm going to have better performance up front. It means I'm going to have really fast lookups and almost no latency. But I'm going to have to deal with the scaling problem when it comes. So I need to ask myself those kinds of questions. Of course, there's another trade-off to consider as well. And that is the idea when something is well supported and mature, it's going to work for me or serve me in some ways, as opposed to if it's brand new, using new paradigms, but doesn't have as much community or support yet, for example. You think of like a well-supported or mature architecture, I might pull up something like MongoDB, which many of you are already using. But there are slightly newer technologies out there, for example, Presto or Hive, which serve as an abstraction layer on top of Hadoop MapReduce jobs. But they offer a more familiar paradigm, namely SQL-like syntax for querying. That eventually is going to get, I believe, more people to adopt them. And in fact, Facebook already uses Presto and is a major contributor to the open source repo there. So the folks at Edureka did a really good comparative study of database types. And on the top left, you have your document store databases, which are a collection of key value connections. Note that this isn't the same thing as key value pairs, which are on the top right. The key value connections actually need a certain amount of munging to do if you want to get, data out of them in a predictable way. Although in the query languages don't necessarily look very easy to stomach if you've ever run queries against MongoDB. Whereas if you're doing querying something like a data model against a collection of key value pairs, you're going to have much faster lookups, and you're going to have stored data, again, with no schema. And no schema, as we'll see in a moment, is actually a relative term, meaning, for example, JSON. Most of the cloud solutions, though, actually use these columnar NoSQL databases. Hive, Cassandra, and specifically Plasma that the company I work for uses. Plasma is a combination of something that's columnar database like HBase for storing the data itself, paired with PostgreSQL for actually storing the metadata about the data. So when you're actually searching, when you're actually running a search on Presto or Hive, you're actually querying against the metadata to get at the data. And this makes for much fast lookups. But like you see at the bottom, one of the weaknesses here is the idea of having a very low-level API that you have to use. That's why Presto or something has to leverage metadata to get at the data, because you don't have the luxury, in a native sense, of being able to write something like SQL against data on this sort of database, which is why everyone's doing MapReduce jobs. And the problem with MapReduce jobs, of course, is that not everyone is a developer, a Java developer. And when that's the case, then there's, of course, a lot of errors that can happen. When I talk about unstructured data, I'm actually talking about multi-structured data. This is data that's coming from many sources. And as we'll see in a moment on JSON, the idea is to be able to pull records of many different types and aggregate and consolidate them into one single data store. So with JSON, you can see one of the key advantages is actually that you can embed objects within objects, and that's why JSON is become kind of the de facto thing. So here in this example, we have a key value pair. The first key is users, and the value is everything in the array that comes after it, including a number of other key value pairs embedded in them. For example, the joined is another example of a key value pair embedded in the key value pair of users, which itself has three key value pairs embedded into it. So it's this hierarchical structure of JSON that serves well in a so-called NoSQL format. JSON kind of ended up recently superseding in maybe the last decade XML because, of course, it's smaller, it's faster, the syntax is simpler, and most importantly, it maps quite easily to anything that's using a key value pair. So looking ahead at some of the architectures, and we'll get to the good Cody stuff in a moment here, Wish.com is one of these examples that actually leveraged both a MongoDB store with low latency on an aggregation server along with a cloud solution to storing data for posterity. So their use case was this. They have an infinitely scalable database running Hadoop and Hive for posterity. And the amount of data in that database is going to grow to infinity over time. It's never going to become less because they're always adding more to it. However, and then they're able to do, for example, long-term analytics on this cloud-based database, which is quite nice. What they're also able to do is very fast queries on the data that's coming in on their aggregation server. So this is a MongoDB solution that's running right off the SSDs on bare metal. So they get the advantage of something that's having both lightning fast for the queries against MongoDB on the bare metal, along with something that's maybe a little bit slower, but can query a much larger data set. So getting to the good open source tools that came out of all of this. Well, one of them is FluentD. Do any of you guys use FluentD for logging? Any of you heard of it? So my colleague Edward is going to do a presentation on a bunch of open source tools, including FluentD, tomorrow, so catch his presentation. But FluentD existed in the bad old days when you pretty much had to write a script for everything. So for ingesting data from, for example, Apache and log files and syslogs and so forth, I needed to write a script to parse data for the log files. I needed to write another script to fetch tweets. I needed to write another script, for example, to parse data coming from mobile applications and so forth. And then I needed to write another script to aggregate it from MongoDB. I needed to write another script to parse it in a format that MongoDB can ingest, and another script to put it in a format that Hadoop file system can use, and another one for MySQL, and so forth. Well, some of the people who created my company also created FluentD, which is a unified logging layer. You can find this at fluentd.org. And FluentD basically lets you unify data collection and consumption, right? So you can configure FluentD to pretty much ingest data from anywhere. It's an open source tool, so you can pull it down from GitHub and play with it all you want. You can pull data from anywhere. You can pretty much send it to anywhere. And of course, it uses JSON as the default format with a bit of configuration. So that is one tool that I wanted to tell you about. Another one actually is MessagePack. And MessagePack was developed in part by our CTO, Mr. Sadayuki Furuhashi. And you can get MessagePack from messagepack.org. And MessagePack is a more compressed format for even JSON. So as you see in the top example, we have a little key value, a couple of key value pairs here. The top version in the JSON, the native JSON, breaks down to 27 bytes. And the bottom version, which is the MessagePack version of this, breaks down to 18. And you might not think that 9 bytes is much of a cost saving, but when you're talking about trillions, that is pretty significant. And the way it works is that MessagePack is compressing, for example, the Boolean true and the 2-element map into a single byte each. And of course, it does this with a bunch of other things as well. You can read all about it on messagepack.org. It's supporting at least 47 languages, including diacritics and so forth. And some of the big shots like Facebook and Pinterest are actually now using it. So key to having a big data solution is having a way to load it. And there are different ways to load big data into a data back end. And one is streaming it directly in real time from the application. The other is querying it and doing periodic bulk loads into the system. And mbulk is actually one such system. This is also one that's developed by the people I work with at Treasure Data. It's another open source solution. And this is a bulk loader that basically it helps you transfer data between various databases, storages, file formats, and cloud services and so forth. So here's kind of an example of what it can do. We can pull from CSV on S3, HDFS, MySQL, Salesforce, or whatever. And depending on the kind of plugins that we have, we're going to be able to load it into Hive, Elasticsearch, Cassandra, Redis, and so forth. A couple of key points. It does parallel execution, so we can have many mbulk processes running at once. It validates the data, makes sure that it's in a valid format. It does recover from error, so as with a lot of bulk loaders, you're running the import and you hit an error and then everything stops. This is actually going to pick up on the next bit and recover. It's deterministic, so we're going to see a little bit about how artificial intelligence in a minute actually drives this thing, and it's able to resume its work as well. So let's have a quick look at it. I'm assuming that I'm going to be able to show my console, but I'm not. What do I need to do to show my console? I think I need to show the other one. So, let's do this. Oh, how weird. Any idea why I can't show my command line on here? Oh, here it is. Never mind. How funny. Now the only problem is that I can't see it. Oh well. Question is, can you see it? I bet now you can. Oop, it disappeared. The joys of not rehearsing things before. Let's see. Okay. Are you guys able to actually see what's on the screen there? Okay. Right, so what we're going to try to do, hang on a second, is we're going to try to actually run a few mbulk commands to do an import. Bear with me one moment, please. You know what I would like to suggest? Is if you want to crowd around my laptop after this is over and we can look at it kind of close up, because I'm not very good at getting all of these screen sharing things to work together. So, and I only have a few minutes left anyway. So I'm going to quickly give you a rundown of the tools, and if you want to catch me later and we can sit together and actually look at some of these tools working together. Sorry about that. Oops, that's not what I want to do either. Bear with me one moment, please. Okay, sorry about that. Another tool you want to know about is Norikra. It's an open source tool. It's stream processing with SQL for everyone. So whereas with engines like Hive, Spark, and so forth, these will stream the queries, but they will also use disks. And the problem you have there is that when you have a very large, either a very long query or a very large data set that it's pulling from, or in the unlikely event that you're actually able to manage a join, which in some of these environments like Hive and Presto you can, in some you can't, you're going to have a lot of memory consumed making the join table, which means you're going to be doing a lot of swapping from the disk. And Norikra is actually an optimization of these, Hive, Impala, Presto, or even RDBMS, in that it streams queries incrementally, it only uses memory, and it does not use disks. So everything is more or less happening in real time and avoids the disk swapping that you're going to have with large HDDs. It's based on the notion that event streams can be split. And it's based on also on the notion that we can stream both queries and results and avoid some of the bottlenecks of query engines. And one of the more fun ones, actually, for me, is HiveMall, also developed by us at Treasure Data. It's basically a machine learning library that runs on Apache Hive. So if you know about Apache Hive, you know about SQL, you know about, for example, user-defined functions that run in SQL. Well, these are slightly more complicated ones that employ machine learning. And you know, with machine learning, you can train a series of nodes to basically learn, for example, how to do a correct classification operation or a correct regression operation, or make a recommendation, find the nearest neighbor, for example, in a very large mapping, detect anomalies, and find basically engineer features and so forth. So as always with machine learning, you have one part which is training the algorithm and the other part which is actually using it. HiveMall is going to be scalable to the number of nodes that you're actually training, as well as the number of features. So what does a big data pipeline, what does a data analytics pipeline actually need to have? It needs to be able to ingest data. It needs to be able to transport data. It needs to be able to run queries, do machine learning, and define and run user-defined functions as well. And it needs to be able to export to other systems. So we can look at a pipeline that enables you to collect data from your application and transport it, store it in the cloud, do SQL-like queries on it, for example. SQL is a familiar paradigm, so if you're bringing over people who are already familiar with SQL, you can put them to work right on big data without having to learn something intermediary like how to do queries on MongoDB. And then you can export the data as you've done it into other systems like analytics and storage and so forth. So this is what such a service might look like. You're going to have your data stored in one very large table in a data lake, and the table may have an infinite number of columns and an infinite number of rows. Why an infinite number of columns, you say? Well, if you're getting data from a variety of sources, like in this example, you're going to have data coming at you with different fields in the data. So, for example, you may have an event log that has a certain number of fields coming from one kind of a source. It might be a web SDK, and then from your embedded SDKs, you may have a different looking field that contains some, or a different looking record or document containing some, but not all of the same fields, right? So instead of trying to engineer an individual schema for each one of these different looking events, what you actually want to be able to do is pull in all the events as they are in JSON, of course, store them in a database, and if this data matches this column, great. If it doesn't match this other column, that's good too. You're just going to have all of the columns there that you need, and you're going to be storing the data this way. So once you have the data, for example, in this kind of a system, then you're able to query it out using an abstraction like Hive or Presto, which is running SQL, but what it's really doing is it's running a MapReduce job on the data in the background. So incidentally, I might know of such a pipeline, but I'm not supposed to advertise here. So if anyone wants to ask me about how such a cloud pipeline works or is set up, I'm happy to talk to you some more. I'm actually able to give you a demo without demoing anything, which will save us, I think, the last few minutes we have, and we'll be able to get to actually seeing how this thing actually works. So what I've created here, if my Sublime behaves and actually shows up, is an iBeacon simulator, which I've already run. I'm going to put it for you out here so you can actually see it. Here we go. How does it actually work? Well, this iBeacon is basically a Ruby application, and it just generates some events. So for example, an iBeacon, do I get a mic so I can walk around? Oh, is it off? Okay, all right, as you can tell, this is the first time I've done it. And these are the kind of events that an iBeacon collects when somebody walks around a store with a device, right? So once we've done this, once we've generated it and run it, we're going to have a node in the cloud. See, I got Mike again. How cool. Which we're going to be able to query against. And I'm going to run you an example query to show you what it looks like. Bear with me one moment because my mouse seems to have gone all over the place again. Right on. Oh boy, here we go. So let's do this. Seems I'm not able to share my desktop very well. Bear with me one moment, please. Right on. I do need help. I'm not able to get this to show on the screen. This needs to go up there. Seems we were all having the same headaches today. So bear with us one moment. We're going to show you how this thing actually works if we're able to. Otherwise, hmm?
Where's your launcher? Can you give the monitors?
Isn't it one of these?
Where's your sublime text?
It's already on the screen.
Yeah, but can
Actually, yes, we can use a little help up here. Yeah.
Move the mouse there, and then to the top of the screen.
Yeah,
Click on the green dot.
That's what I try to do.
Again.
Yeah, good luck with that, huh?
Yeah.
Oh, right.
Now it's an application.
Now it's going to just... We need to get this out there. Sorry about this, folks. Please bear with us for one moment. And my mouse has completely disappeared. How fun. Demos are great, aren't they?
There you go.
Okay, thank you so much. So, so we've generated all that iBeacon data, and we're going to run it in the cloud. So can you see what this actual query says? We're just going to count the number of records we got. So if the mouse actually behaves, then we're going to run this. Sorry about the inconvenience. And it looks like the network hung as well. So, so yeah, trust me, it works. It's a great thing. But it looks like we're not having much love from the network right now. So that is unfortunately all I've got for you. Are the slides going to be available somewhere so you guys can download the tools and try them yourselves? Okay, so the slides are going to be available from, hey, is it working now? No, it's not. Okay. Does it say kill me? That would be appropriate right now. Sorry, guys, don't have the demo working, but you kind of get the idea, I hope. Thank you for watching. All right.
you copy our slides here?
Yeah, I
So
can do that.
upload it to everybody.
Okay, yeah, I'll
There's
do that.
a question. There's an app that smartphones that audience can make questions, and we upload the slides there, so everybody will
Perfect.
have access to it.
Yeah, I can do that.
That's what you signed, actually.
Yeah, I know.
Speakers.
Mm-hmm.